Back again. So what we're looking at is depreciation still. We're still looking at diminishing value method. But besides drawing up a schedule, another thing we can do, which can make life a lot easier and a lot quicker, is to actually use a formula. Now I've snipped this one out of the textbook again, just to make a point. Again, we have a new formula. And again, I prefer just to use one formula for everything, if I can avoid using new ones. So when I look at this, hopefully you'll note that future value, like before, will be the amount. Present value, like before, will be the principal. The big difference about this is you just have to think. So in compound interest, in appreciation, everything is going up. Now on this one here, we're talking about depreciation, so things need to go down. So when things go up, we add. When things go down, we subtract. So when we look at using the compound interest formula rather than this, we have amount equals principal, 1 take R over K times 100 to the power of K times T. So the only thing which has changed is that instead of plus in the middle, we now have subtract. Everything else about how we solve these problems, all the strategies, all the working out we've done before, as you will see when I do a couple of examples, is exactly the same. You just need to remember if it's going down, which means it's diminishing, we are subtracting, we are not adding. So, let's have a look at a couple of examples for this. So when we look at this one, a car is now worth $24,000, so it depreciates. Like the words appreciate, compound, you just need to know what these words mean and what their formula is. So depreciates, compound interest formula. Amount equals principal, 1. Now because it's depreciate, we've got to remember going down, so we're subtracting. And we fill in the formula, so that's the same formulas we've been using except for that little change. We fill in what we know. Our car is now worth. That means principal. If you want to use the other formula, it will be present value. R will be 15. T equals 5. So like before, K will equal 1. And the thing which we're missing is our amount. So we start filling in our formula. Amount equals 24,000. 1 take 15 over 1 times 100 to the power of 1 times 5. So, really, I don't know why I wrote that again, because we can put this straight into our calculator. And what you should end up getting is your amount equals $10,648.93. Now, for really good communication, you really should be putting a statement at the end. Now, occasionally I forget to do that. Please don't make my mistake. So at the end, the car will be worth $10,648.93 in 5 years. So that's the diminishing value one. So it's very, very similar to the other ones we were doing, except for that subtraction component. So let's look at one of the hardest sort of questions when it comes to this sort of stuff. So Jules bought a fairy floss machine for a sideshow. He estimated that 6 years will be worth only $1,500. What percentage depreciation should he use? There's that magic word, depreciation. That means that I'm using my compound interest formula. the magic word depreciation means I use subtract. Write down what I know. He bought for 6,000 and he reckons it's going to be worth 1,500 in the future. So currently, which is principal, it's 6,000. In the future, which will be amount, it's 1,500. And that's time is 6 years. K will be equal to 1, and we are looking for the rate. So we fill in what we know. 1,500 equals 6,000. Now, some people would have gone, oh, sir, shouldn't those values be around the other way? No, because you've got to remember, in this case, we're going to be losing money. So the amount of money we have in the future should always be less than the amount of money we got now. So just be careful not to make that mistake. So our rate is the thing we don't know. We're going to make K1 because it's not mentioned. And I'm hoping that some of you are already seeing how we start solving this. So I'm just simplifying things down a little bit now. So the first thing we need to do is get rid of that 6,000. So it's multiply, we divide. So we have 1,500 over, well, I wrote 15,000. That's wrong. It's 1,500 over 6,000, which should end up being 0.25, I believe. Fill in the rest of our formula. So I did work that out before. So that's 0.25 equals 1. Take R over 100, all to the power of 6. So I'm just going to bring this up so we've got a bit more working space. So we have 0.25. Now remember, to the power of 6, the opposite of that is root 6. So if we put the root 6 of 0.25 in our calculator, we get 0.7937. Now you're going to notice something very interesting is going to happen shortly, but we'll run with it. So we get rid of the 1. To get rid of the 1, we take it away. Now your calculator is not lying to you here. The answer will be negative. Okay. What I'll point out to you is obviously you can't have a negative rate. I said that before. But if you'll notice, both sides are negative. So if we divide a negative by a negative, we get a positive. So essentially, they disappear. So we end up with 0.2063 multiplied by 100 equals R. And R is 20.63%. Again, what you should notice is that percentage really should be between 0 and 100. If it's not, check what you've done. You've probably made a mistake. And that is the diminishing value formula.